Okay, guys, here we go. Page 616. So, what we're talking about right now is, and I want you to write this down on this page. So, you guys, we are talking about what is known as the quotient rule. Okay, we're going to be applying what is called the quotient rule. Now, if that word quotient does not ring a bell to you, if it sounds unfamiliar to you, the word quotient is just a fancy way for saying you're dividing. Okay, so some teachers, not many, but some, they call this the dividing rule with exponents, but we call it the quotient rule. Quotient means the same thing as divide. Okay? And here's what the quotient rule tells us. The quotient rule tells us that if we are dividing two numbers that are in exponential form, like a to the exponent of m, and if we're dividing it by a to the exponent of n, and if you didn't know that, that line right there, which indicates a fraction, is telling you to divide. The quotient rule says in order to simplify such a problem as this, what you do is you leave the base as to whatever it is. So if the base is a, you leave the base as a, and then you subtract the two exponents from each other. So you would take the exponent of m, and from it you would go minus the exponent of n. Okay, you guys, that right there is the quotient rule. All right? Using numbers instead of letters, so that means that if I said, what is x to the 9th power divided by x to the 3rd power, according to the quotient rule, you leave the base as x, and you subtract the exponents. You don't divide the exponents. You subtract them. So you would go 9 minus 3. So this problem, x to the 9th divided by x to the 3rd, would simplify down into x to the 6th power. Okay? So you guys, that's what we're applying today. And that's what, from the new set of problems that you're going to get assigned, you're going to be using the quotient rule, which is this rule right here. Okay? So we're going to do problem example A. So notice in example A, we're dividing. Notice both of the expressions have the same base, which is y. But if you notice, the exponents are fractions. Okay, you guys, it doesn't matter if the exponents are fractions. You still use the same rule. So to simplify y to the 3/4 power divided by y to the 1/2 power, you're going to apply the quotient rule. The quotient rule says leave the bases as they are. So if the base is y, your base is going to be y, and then what do you do with the exponents? You subtract them. Okay? So you're going to go 3/4 minus 1/2. And notice it's always the numerator's exponent then minus the denominator exponent. Okay? And then you would have to work this out. Now you guys know that you cannot subtract fractions until they have a common denominator. So I would have to change both of these numbers right here to the same number. So what's common denominator between 4 and 2? 4, yeah. So when I change this, I'm still going to have a base of y. 3/4 will not change, but then I'm going to have to go minus, and what would 1 over 2 would become what over 4? 2 over 4, and then you subtract. So this would give me a simplified answer of y to the 1/4 power. Okay? So y to the 3/4 power divided by y to the 1/2 power, when we simplify it, becomes y to the 1/4 power. All right, so you guys will just realize that when you're using the quotient rule, you subtract the exponents. It does not matter if the exponents are fractions or if they're whole numbers or negative numbers. And we'll look at like all cases. Okay, so moving down to C, we have k to the 6, j to the 2nd, divided by k j to the 5th. Okay, so the quotient rule is the same even if you have multiple bases. So we have bases of k and j. So you guys, when this happens, you work alphabetically. So let's start with the k's. Let's simplify the k's. So I'm going to keep the base of k, and then remember the quotient rule says subtract the exponent numbers from each other. So you're going to take this top k, which has an exponent of 6. Then you're going to go minus, what's the exponent on the k on the denominator?
1.
A 1. Good. So you're going to go 6 minus 1 for the k's exponent. Then for the j exponent, you're going to do the same thing. You're going to go 2 minus 5. Okay? And you'll notice that every once in a while you are going to get an answer that has a negative exponent in your answer. So simplifying this out, we get k to the 5th power. 6 minus 1 is 5. J to the negative 3rd power. All right? Now remember, don't leave your answer with a negative exponent. What do you have to do when you get a negative exponent in your answer? Right, you have to turn it into a fraction. So when I write my final answer, I'm going to have a fraction. Where's the k to the 5th going to be? On the numerator, the top of the fraction. And then you're going to move the j down to the denominator, the bottom of the fraction, but then the negative 3 becomes a positive 3. So simplifying this, k to the 5 over j to the 3. Now, here comes like my best question I'm going to ask all day. Can you guys subtract the 5 minus 3 now?
Yes, sir.
No.
Yeah, the answer is no. How come you can't subtract the 5 minus the 3?
It's not the same base.
Right, not the same base. You can only apply this quotient rule when you have the same base. So is there anything more I can do than what I have right now?
No.
Nope. That's your answer. So in part C, we get k to the 5th, j to the 3rd. All right? We good so far?
Yep.
Okay, move down to number 2 at the bottom of the page, number 2. Okay, on number 2. Now, if you notice on number 2, I have A's, B's, and C's. So I'm going to have to work through them in alphabetical order, but I also have a 12 and a 4. Okay? And if you guys recall from last week, the 12 and the 4 have a name. Anybody remember the name of a number before a letter? Coefficient. So, what do you think you do with the 12 and the 4? Do you think you subtract them, or do you think you actually divide them out?
Divide them out.
Yeah, so you guys, you treat coefficients like normal numbers. And you don't do any special rule with coefficients. So to simplify this out, you would actually go 12 divided by 4, which is 3. Then we're going to use the quotient rule to simplify the A's, the B's, and the C's. So to simplify the A, we're going to go negative 1 minus 5. To simplify the B's, we're going to take the top exponent, which is 6. Then we're going to go minus, and what's the bottom exponent for the B?
-1.
It's negative 1. So please notice, you guys, very important, notice how I wrote the B's. I went 6 minus negative 1. Okay? It's always the top exponent, then you put the minus sign, and then you put the bottom exponent. A lot of students in the B, they make the mistake, they write 6 minus 1. It's 6 minus negative 1. Very big difference between the two. And then for the C's, I'm going to go negative 3 minus 5. All right? And then I'm going to simplify this out. What's 12 divided by 4? 3. A. What's negative 1 minus 5? So I'm going to get a to the negative 6. For the B's, what's 6 minus negative 1? 7. B to the 7. C to the negative 8. Okay, so I have 3, a to the negative 6th power, b to the 7th power, c to the negative 8th power. Now I have to turn my answer into a fraction because I have negative exponents. Okay, so when I write my final answer, I'm going to have a fraction for an answer. Where should the 3 be? Should it be on the numerator or the denominator? Yeah, the 3 is going to be on the numerator. Okay? The 3, you guys, that negative 6 exponent, is it for the a or is it for the 3? It's only for the a. So technically this 3 has an exponent. It's a 1. So I'm going to leave the 3 on the numerator. Now, where should the a go? On the denominator. But then the negative 6 becomes a positive 6 exponent. Where should the b be at? The numerator, the top. So I'm going to have a 3b to the 7 on the numerator. And where should the c go?
Denominator.
To the denominator. So on the denominator would be a c to the positive 8. There's your simplified version. 3b to the 7th over a to the 6th, c to the 8th. And then once again, can I subtract 6 from 7?
No.
Can I add up to 6 in the 8?
No.
No, because they're all different bases. So once we have all different bases, we're done. All right? Questions? Or are we kind of getting it? Okay. Turn it over to 618. Okay, guys, let's talk about raising a quotient to a power. Okay? So, here's the rule. Quotient to a power. And I have this on the board over here, but I'll write it again. You guys, that means 3 divided by 5. Okay, that's why we call this a quotient. Remember, the word quotient means divide. This means 3 divided by 5. Then, if I put a 2 outside the exponent, you guys, this power of 2 applies to everything on the inside of the parentheses. So, this power of 2 applies to the 3. The power of 2 also applies to the 5. So this would become 9 over 25. Okay? So what does that tell us? It tells us that anytime you have an outside exponent, like in our example here of 2, and then you have in parentheses a fraction, that outside exponent applies to everything on the inside. Okay? So this exponent of 2 applies to the 4. So if I were to simplify this problem, it would become 4 to the 2nd power. And then this outside exponent of 2 also applies to the 3. Okay, now what do we do with an outside exponent of 2 and an inside exponent of 3? Yeah, you multiply. So for the x's, you would have to go 3 times 2 for the exponent. Okay? 4 to the 2nd power is how much? 16 over x to the 6th power. Okay, and that would be your simplified version of part A. Okay? Now, when we get down to part B, notice that we have a to the 3/4 power over a to the 5th power in parentheses. Then we have an outside exponent of 4. So you guys, we have to use the quotient to a power rule here. Okay, so that 4 outside, it applies to both the 3/4 and it applies to the 5. So to simplify the top, I would have to go 3/4 times 4. And to simplify the denominator, I would have to go, I'd still have a base of a, and then I would have to multiply 5 times 4. Okay? And then I would work this out. So that would simplify to, here we go, somebody could be able to think of 4 as 4 over 1. What's 3/4 times 4 over 1? Think of 4 as 4 over 1. What's 3 over 4 times 4 over 1? That'd be 12 over 4. But what's 12 over 4 become? 3. So the numerator would become a to the third. The denominator would become a to the 5 times 4, which is 20. Okay? And then you guys, are we done, or can we simplify this further? Yeah, which rule would you use now to simplify a to the third over a to the 20th? Yeah, this would be the quotient rule. So what do you do with the 3 and the 20? Subtract them. Now, should you go 3 minus 20, or should you go 20 minus 3? No. You wouldn't go 20 minus 3. To simplify this, you would keep the a, and then you would go 3 minus 20. You guys, when you use the quotient rule, you always take the numerator exponent, and then you subtract the denominator exponent. What's 3 minus 20?
Negative 17.
Negative 17. So this problem becomes a to the negative 17. But now what do you have to do to write your final answer? You got to flip it. So what's my answer? 1 over a to the 17th power. Okay, so that's what part B would simplify into there.